Hi and Assalamualaikum warahmatullahi wabarakatuh. So today, our group are going to present MAT523 group project related to least square and best fit curve. Before we start our presentation, let me introduce our group members. My name is Mizan Kamalia and we have Alia Umairah, Ami Firdaus and Rus Amira Arisha. For our project, we choose title The Number of Deaths Registered in Malaysia. So based on the data obtained from the data recorded by the Department of Statistics Malaysia, the annual death by sex and ethnicity dataset provide the yearly record of total deaths registered in Malaysia for both sex and all ethnicity. The dataset include attributes such as the date, year, sex, ethnicity, crude death rate, and the number of deaths. For our analysis, we only focus on the annual number of total registered deaths in Malaysia across 10 years. We selected the period from 2014 and 2023, where the variable X represents the year, starting from the year 2014, and variable Y represents the number of total registered deaths for that year. Hence, the table below represents the selected 10 annual record.
My name is Ali Umaira and I will continue with the implementation of mathematical model by using Maple. First, we will look at the linear model. The first step that we need to do is to plot the data points. There are two variables, which is x and y, and we will list out these variables. So for x is the years from 2014 until 2023. Meanwhile, the y is the total registered death. Next, we will move on to linear approximation. For the first step, we need to define AL, matrix A, and also matrix AY. So for AL is a column vector of 1. The next one, A, which is a matrix that has 3 columns, where the first column is the column vector 1, the second column is value of x, and the third column is the x squared values. And the third matrix that we need to define is AY, which is a augmented matrix of A and Y. After we get the matrix AY, we can solve it by using reduced row echelon form or RREF. And in the end, we will get as shown. Therefore, it is inconsistent system. Since our system is inconsistent, we can use normal system, which is A transpose AX equals to A transpose B. So first, we need to find the A transpose, where we denote as AT, which is equal to transpose of A matrix. After we get the A transpose, we can find the A transpose A, which is AT multiplied with A. Then, we can continue with the determinant of A transpose A, where it does not equal to 0. This shows that it has a unique solution. After that, we can find the A transpose B, which is AT multiplied with Y. Since we already have A transpose A and also A transpose B, we can continue to compute M, which is augmented of ATA and also ATB. Then, we can solve this by using RRAF. So, we use RRAF on the matrix of M. Therefore, we will get the final answer, which is as shown. So, the graph shown is the quadratic curve graph, and it has the positive relationship with an uptrend. However, around the year of 2020 to 2022, we can also see that the data points have strayed away from the fitted line. Therefore, we can say that it has non-linear trend.
Next, we go to the implementation of mathematical model manual calculation. Linear model. Linear model y equals to a plus bx plus cx squared. We substitute the value of x and y into the equation. Next, we need to find ax equal to b. We need to check whether the system is consistent or inconsistent. We check by using reduced row echelon form. For the first step, row 2 until row 10 will minus row 1. Next step, row 3 minus 2, row 2. Row 4 minus 3, row 2. For the third step, row 2 will divide by 2. And for the last step, row 4 will minus 6 row 3. Since there is 0 equal to negative 17799, therefore the system is inconsistent. Since the system is inconsistent, we use normal system A transpose AX equal to A transpose B. We find A transpose A and A transpose B. After we get the value of normal system, we need to find the determinant of A transpose A to get the type of solution. After we find the determinant of A transpose A, we get the determinant is 435600 is not equal to 0. Therefore, there is unique solution. After we get the type of solution is unique solution, we need to solve by using reduced row echelon form. So this is step by step of reduced row echelon form. After we use reduced row echelon form, we substitute the value into the equation y. So y equal to 46481292.5 minus which 466356.2438x plus 117.298692x squared.
Now let's continue by looking at the error vector and the magnitude of error using maple. The error vector calculation will first define the solution vector, denoted as n. These vectors hold the estimated coefficient we previously found. The maple command to define n is shown on the slide, and the resulting column vector is displayed on the right. Next, we calculate the error vector itself. The error vector is defined as the difference between the observed data y and the predicted value a dot n. The method command for this calculation is err equal to y minus a dot n, and the resulting error vector is shown below it. Following the error vector calculation, we determine the overall size of the error, which is the magnitude of error. We calculate the magnitude of error by measuring the total length or size of the error vector. This gives us the final square root number like shown on the slide. Finally, we visualize this error by plotting the residuals against the independent variables x, which is the years. Based on this graph, we see the data point plotted between the years against the error. However, it has a clear pattern and is not randomly scattered around the zero line with large positive and negative deviations, especially after the year 2020. This specific pattern shows that this fit model does not capture that overall trend properly, with the prediction error significantly increasing in the later years. Therefore, we can conclude that the model does not fit the database. Next, let's take a closer look at manual calculation to find error vector and magnitude of error. To calculate the error vector manually, we apply the formula E equal to P minus AX. This involves taking our observed data B and subtracting the predicted value AX generated by our model. The slide clearly illustrates this element by element subtraction process. After performing all the calculation, we arrive the final error vector, which is the column of negative residual shown at the bottom of the slide. This vector represents all the remaining error from our model. To find magnitude of error for manual calculation, we manually square each error number, add them all up, and then take the square root of the final sum. The total of the square error equals to 1.4669205 times 6 times 10 power of 13. This calculation leads us to the final magnitude error, which is A equal to 3830029.838.
Last but not least is the error graph. From the graph shown, we can see that it is not randomly scattered and it also has pattern, especially on the early years. And then after the year of 2020, we can see that it dispersed quite large from each other. Therefore, it does not explain the overall trend properly. then we can say that this model does not fit the data well. Hence, it is advisable to use cubic instead. That's all from us. Thank you very much.